All right, we'll go ahead and get started. Hi, everyone that is joining us. Welcome. As you can see on the chat below, please feel free to chat anything. We'll use the Slido link, which is over to the right if you click on Session tab. It's named Slido. Please use that for any questions, and we'll probably just go ahead with questions after the presentation. But I will kick it off to Ryan from here.
Well, wonderful. Thank you so much. Let's dive in and get started. Julian?
Yeah, so basically we're going to talk a little bit about who we are and then describe the issue, which was basically the integration between two systems that had APIs and why it might be applicable to other folks who are dealing with various products that have APIs and may not have an out-of-the-box integration. We're going to dive into the details to show you how to do it, and then we'll have a little time for Q&A at the end.
All right, awesome. So my name's Ryan, at least that's what my mom tells me, and I've been working in security for about 15 years. I'm the co-author of AWS Detective, as well as a published author on threat hunting and incident response. And this is my colleague Julian, and I'll let him introduce himself in his own words.
Hi, everyone. I've got about 5 years on Ryan and started working in Las Vegas in CRM and then moved to technology for security that was detecting non-obvious relationships between lists and manifests. Then I switched over to IBM, started working on encryption and a few other things. And then I found out about OS Query and fell in love with OS Query and started working with a company, Uptycs, 2 years ago. And that's what we're going to talk about today, how we integrated Uptycs with our ticketing system, Opsgenie.
Awesome. So the first thing we really want to talk about is, what is the problem, right? I need it, I want it, it doesn't exist, right? The lack of the integration means that I cannot easily take the detections I'm getting from one source and findings from that EDR solution, in this case Uptycs, and put it into my existing incident response workflow, which in this case is Opsgenie. But this is just one example. This translates also to other common ticketing systems. Say you have, New Relic or something like that, and you want to generate alerts in Opsgenie the same way, or a different ticketing system. The same kind of technique is going to apply. So because of this difficulty, it also means that I cannot easily replicate, duplicate, share, or even modify my existing solutions. So these are all really core issues of when you want two different services to really talk to each other without an existing integration. Now, probably what you care at this point is, or saying is, why do I care, right? And it's really simple. Right. In this kind of API first world where we're looking at SaaS tooling becoming the default rather than the exception for how services are rolled out, especially ones that your team are going to be using in the enterprise. So not all vendors play nice together. And probably the hardest part is not all of them want to. So this leaves the end user, which is you, to make it work. And why do we want this to work so badly? We want it to work really badly because we have these two service solutions that we use in our critical path workflow, and we need them to be able to communicate together so that way we can be most efficient and also most effective with our findings. And Julian's going to tell us a little bit about why our source is so important.
Yeah, exactly. Thanks, Ryan. So the source in this particular case was the Uptycs platform, which really captures data through an OS query agent. So for those folks that have used a lot of different endpoint agents in the past, they know the challenges of, this endpoint agent collects this information, a different endpoint agent collects a different piece of information. Some of them are high resource utilization. And Facebook ran into this problem and wrote a brand new agent called OS Query. And it's really neat because you get 267 different tables worth of telemetry across Mac, Windows, and Linux. So you can see here, these are the areas of telemetry, 155 of them specifically on Linux. So you can tell everything about your systems, whether it's slowly changing configuration information about the firewalls, or whether it's very detailed information about all of the commands that were run on a system, the processes that were running, what PIDs they had, what were their parents, the network information, like what was the socket event activity. So all of that you can capture with OS Query. So it's a really powerful agent. And what we did at Uptycs was we used that OS Query agent to gather the telemetry from all of the endpoints, as I said, whether they're Mac, Windows, or Linux, or whether they're containerized as well. So if you have containerized environments, that OS Query agent can get the data for you. Now, with Uptycs, what we do is we collect, aggregate, and analyze that data. So we take it all in, and then we store it in a historical flight recorder. And as it's flowing in, we do a lot of different analysis. We have a bunch of intrusion detection rules that can generate alerts based on certain conditions. Those could be out-of-the-box rules or rules that you've created. And those were the data that we wanted to send out to Opsgenie. Moving on to the next slide. So Uptycs has a really nice way of storing the data and letting you ask questions of that data, so you can see what's going on right now on your fleet, or you can go ahead and ask a question back in time. So if you had a breach 2 weeks ago and you wanted to see exactly what commands were run on those machines, who logged in, you can see all of that through our time machine. Moving on to the next slide. With all of the data that we have stored in the time machine, as it's flowing in, we have a whole bunch of detection rules. And these detection rules are looking for malicious activity. They're correlating to known indicators of compromise with the threat intelligence data that we've loaded into the system. You can load your own data, your own threat intel if you like, or from an ops perspective, you can set up rules to say, tell me when a new user was added, or tell me when this was deployed. What version was it? Did it have any vulnerabilities of the packages that were in there? So there's a lot of flexibility there with out-of-the-box rules. Now, you can use those out-of-the-box rules, or you can create your own. So there's wizards in there where you can say whatever condition you want to check whatever data element you want. If it's there, you can create allow lists and block lists based on the existing activity that you're seeing in the Uptycs platform, to create like a golden list of things that are okay, and alert if something is outside of that list. Moving to the next slide. And so with those rules that you've either used out of the box or created your own, you can generate a bunch of notifications, alerts, and you can look at those inside of the Uptycs platform, or more often you'll want to send those to a SIM or a ticketing system. So in our particular case, we really wanted to send those to Opsgenie. Next slide. But in our particular case, Uptycs has a bunch of out-of-the-box integrations, but Opsgenie is not one of them. So what did we do about it? Basically, at first we started crying, and then we basically started drinking coffee, and then working out, how are we going to build a solution? I already had some experience with Python, so we built a POC with Python, where we basically would call the Uptycs API to get that alert data, and then do another set of calls to the API in the target system, which is Opsgenie. So we built that out, but then we decided, no, we want to do it a different way. We'd really love to use Postman. We'd really like to do a pure API to API approach, because it's very flexible. Most tools nowadays have an API. And so if you can use something like Postman to build a general approach where any input system with an API and then any output system with an API would really be reusable. So that's what we did. Moving on to the next slide.
Yeah. And thanks for that explanation, Julian, because one of the things that I really want to hammer in is how important that source data is for us as part of our incident response workflow. So what we want to kind of show is how you can do it too. And as much as I hate to say these things out loud, but RTFM, how else are you going to understand how the different services work? So, you Google it and you're going to thank yourself later. That 10, 15 minutes you spend reading some information before you start poking is going to save you a lot of time later on, even though it's nowhere near as fun as searching Stack Overflow for things that don't work. So the first thing that I did when I wanted to create this solution was I started to kind of map out the fields I wanted to populate on the destination side. So in this case, on Opsgenie, what fields do we want to populate and what kind of data goes into those fields? Working backwards from there, we're able to map that data from the source. So once we had those mappings, we had a pretty straightforward way, logically, to kind of build these blocks up together to list the alerts from that source and push them into that destination. And from there, we had a game plan and we started to RTFM, right? Because now we need to figure out what are those fields called? How do we actually query them? Are they able to be accessed via API or not? Those kinds of things. And then finally, I can't say this enough, but please don't use production anything if you don't have to, especially when setting up and testing. Never hard code credentials into your requests or things like that, because if those collections or those requests get shared somehow, your credentials are in it. So instead, try to leverage some things like environments, which allows you a couple of really big benefits. The first one being that there's two values. There's your initial value and your current value. The initial value ones get shared with the collection, but your current values do not. So that's one way to keep things kind of private to just your local instance. But then also you can use multiple environments. And what that allows us to do is it allows us to reuse that code. So it's easily shareable, easily repeatable, and it allows us to test in stage. So we create one environment with stage credentials, and we create another environment with production credentials, and so on and so forth. And then we can just reuse the same requests and code. All we have to do is switch which environment we're using. And that's quick, easy, and allows us to hit different accounts, different regions, all that kind of fun stuff.
Yeah, so here's a little slide shows some of the environment information that we had to determine for Uptycs and also for Opsgenie. So, with Opsgenie, we needed to know what was the ticket that we were creating, who were we creating it for, what were some of the details of the alert. For Uptycs, we had to pull that various information. So in the environments, we had to capture all of that into variables and define the critical variables for the API interface as well. Moving on to the next slide for the headers. So we had to define those headers, and this was really the hardest part for us. We had to look at both the source and the destination, but unfortunately those didn't use a standard API or OAuth authentication. So in that section we could have spent a few hours on, but basically we could share for every implementation. I would say, go ahead and read up on that solution's API. Or ask for a technical contact for a hand if it requires something unique. If you're able to use one that's standard, you're going to be so much happier.
Yeah, and that was definitely one of the things that tripped me up a whole bunch during this. So after you're able to authenticate and actually start querying things, here we have an example query that we're using to pull the data from Uptycs. And one of the things I want to kind of draw your attention to are the escaped quotes. If you saw them right off the bat, you're better than me, because I missed them the first 50 times I tried to make that query work until I figured out it doesn't accept queries with that kind of type. Now, this is all part of that RTFM kind of process, right? In the end, a random Google search I had for syntax ended up leading me to this idea. So, I had that good foundation between reading the documentation of source and destination to get a pretty good idea of how I'm going to ask these questions. Then I was able to write a query inside one of the products that returned the data I wanted, And at that point, I just had to figure out how to translate that into the body of the request that's getting sent. So with that, let's talk a little bit of code. I'll admit JavaScript is not one of my strengths, and neither really was this type of work previously. I'm more of an architect than I am a programmer. So as you can see in this very simplistic code is me just using a post request to parse the response body into JSON and then populate environmental variables with the values from that. What I'm doing here is just setting a run counter so that I can loop through the number of returned objects, and that allows me to kind of increment each loop of requests forever until all of them have been issued. Then the script will exit. Here you can see me calling the specific attribute set next request to call a specific request to go next, and if the counter has run out, to return null and not go on anymore. So let's talk about some of that data that we had to parse. So the example of the response body from the request. So here's about 2.5 of the 50-ish items that got returned from the query the first time I ran it. And you can see from the JSON objects returned that this is going to be easy to handle and parse. Yes, JSON. All right. The unstructured data, it makes me a sad panda, but it's possible to parse through. It just takes a whole lot more work. You know, you might share that opinion, you might not, but in this case, I really am so happy it was just standard JSON objects. To kind of break this down a bit more, the send to Opsgenie request is very tiny, really, because all we're doing is we're authenticating to Opsgenie and we're passing it a message body from the data objects that got parsed from the Uptycs request response. Then I call set next request to go back to the Uptycs request to continue the loop until all the objects have been parsed and passed. By using this set next request, I'm able to create a request loop, which allows me to do that automated integration for however many objects I had. So it's reusable, it's incredibly scalable, and the best part is that I can run them in parallel. So if one of the requests hasn't finished yet, you know, the next one is going to continue to pass through, so they can work in parallel, or we can slightly modify the loop and have them run in series. Either way, you'll either have max performance or you don't have to really worry about having race conditions or problems like that. But one of the things that's kind of interesting is the output of a manual run, right? Oh God, we're gonna run it. But the loop is being executed as well as the counter being used. I like having this kind of in my console output because not only does it tell me each request is successful or failed and which loop it was, but it also tells me kind of how many I've got left to go through. I find that tracking incredibly useful. If I ended up implementing this into production and this, you know, ended up creating too much data, I can obviously silence some of these alerts. But for the development in my beta and stage environments, doing a brand new integration where I don't know what the service is going to be like, all of those problems I'm going to try and solve here by having a couple of these outputs. I'm sure better programmers have better ways to do it, but this is my equivalent of, you know, a print statement in my Python code. Now, the pros are that everything worked. The only con is, holy crap, that is a lot of alerts. So hang in there. We're going to get through these, and we're going to use the results to improve our security posture proactively. All right. So digging into these, we can see that one of the alerts here, it's populating all the required fields with the mappings from the source destination. So that's that first thing that we defined as part of the process. And then in order to not lose any of the data, what we did is we took the entire JSON object that we already had and we put that into the extra properties field. Now, this gives us kind of a win-win scenario because it allows us to populate the mapped fields, which give us the fastest query ability in Opsgenie because those are indexed and they're more easily accessible. But I also don't lose any context. because I can go into the alert and go down to the extra properties field, and I can see all the properties that were returned. And it also makes them searchable within the console. So what I'm really doing by this integration is I'm leveraging that built-in capability of my destination service that I found through documentation. So originally, when using a product like this, I didn't know that I could search through the extra properties field. I thought I could only use the index fields, but you're actually able to search both. So that was a big kind of win for us there. And then finally, we want to try and operationalize this, right? You can schedule it as often as you want. Since this is a EDR solution to Opsgenie, we went with the shortest time, which in this case is about 5 minutes. And it will run through each request in the collection. And as you might have been able to see on the query that we showed you, it basically grabs the current date and time and subtracts 5 minutes from it and makes that the timestamp to query within. So that way we have that time box to work with. Now, here we want to stay up to date on the health and performance of the APIs, right? So within a matter of a couple of seconds and just a few clicks, we're able to set up a Postman monitoring service and integrate that into our API development pipeline. And what that's going to help us do is that's going to help us monitor how often it's running and how successful it's been while running. And now we see here that it's alive, right? We can see it working. We can see it running every 5 minutes. Yes, I chose 5 minutes so I could populate that graph, but it still looks pretty. And what's awesome about this is now it's automated running. So that one collection run that we showed that successfully went, now that collection is going to kick off every 5 minutes. And not only am I going to get those alerts getting sent to my proper destinations and places like Slack or email or what have you for the alerting, I'm also able to get alerts on failed runs and monitors right into my email. So I know that, say the API token ends up expiring, it's going to start failing in the monitor. So this will let me know when it fails, and it'll have all those attributes to actually take that one-off collection where you have a single use case for it and turn it into something more operationally sound. What's great about this is that we published these collection documents. So this Uptycs to Opsgenie integration is up on Postman. I have it in the reference slides, the link to it. So you can go and download this collection now. You can import it and use it. You can run it through the documentation service that Postman provides. But we really wanted to show here is a working example of taking from one source, parsing, manipulating that data as we see fit, and then pushing it to that destination and making that entire pipeline as seamless and as efficient and repeatable as possible. And with that, I want to thank you guys for your time and attention today, and especially Julian for assisting with all of this and the awesome work that we did together. So kind of remember my motto: flag it, tag it, and bag it. And I'll leave it to Julian before we have any final questions. Julian?
Yeah, just want to thank everyone and open it up for questions.
All right. Cool. So let's hop over to Slido. As you guys can see, I don't have that directly in front of my face, so let's move this. All right.
There are no questions on the show right now, but please don't anyone be shy. Go ahead and put something in there.
I'm okay with you guys admitting that it was the best presentation you've ever seen, and I have solved all your problems. And the last slide just says 42.
Well, I would agree with that, Ryan. I've got one question actually for you, Ryan. If there's not any from anyone else, what, if any, enhancements would you see to Postman to be required if this was to be, a real scalable production solution, pulling maybe a large number of rows from one system and pushing them into another system?
Yeah, so one of the really cool features of Postman is that you have both a desktop client and a web client now. So one of the things that You see, if you need more memory or you need to store things local, you can switch between the clients to take advantage of their native resources. The web-based one is going to allow you to store a decent amount of data in memory, but that, with like Chrome and things like that, memory management is really important for us. So if you're going to be doing things with like a couple of gigs of data, when you're testing, you want to try using like the desktop client and things like that. But what's wonderful is that you can use both for this case. And second, I would also like to see that we go in and start creating more authentication types. So the technique that Uptycs specifically uses for their authentication is not rare and weird. It's just one that has not come up in popularity to the same level as OAuth and things like that. So I think by adding some more authentication preferences and mechanisms into the product by default, that's going to help other people scale with other applications that don't meet these really popular standards that are already in existence. Got it. Thanks. Yeah, see, Prashant's asked if we can put the link to the collection in the chat. Yes, I can. In fact, let me exit out of this and grab that for you right now and toss that in. So that's in the chat now, just so everybody can have it. And you can all see my comment to Julian about, hey, I just added it to there. One of the really cool things that I found with this document service has got to be how easy it was to actually like create this documentation. I was just like every other person that really loves to script and kind of poke around and break things. Documentation was not the first thing I thought of when creating this. So when people were like, why don't you create a document? I was kind of dreading it, but I only had to click a couple of buttons and it populated all of this interactive documentation for me, which was just really awesome. It really saved me a ton of time. And in the end, all I had to do was, update a couple of text fields, and now I have great descriptions and things like that. And that was so much easier than doing it.
Yeah, I see that, I'm getting a 500 error as well on that that particular link, but we'll get. Yeah,
I'll go back and make sure that's public.
We'll make sure that's public, so it'll be active in the future. Well, I know you've got about a minute to jump on to the next session, so I wanted to thanks everyone again. Thanks, Brenna.
Yeah, wonderful. Thank you for your attention today, guys.
And everyone that's in this session, please feel free if you have any other questions, you can stay in this. It will eventually just close out, but please feel free to join some of the other sessions that are happening. And then we'll have our closing ceremony, and then we have some fun activities after the closing ceremony as well. So stick around for those. So thank you, guys.
Thanks, guys.
Thank you.